Hi, this is Dr. John Bergduff. In this video, we're going to explore dividing polynomials. Now, when we divide polynomials, the result we will get will be a polynomial called a quotient with a remainder that we can write as a remainder divided by the divisor, which actually is exactly what happens as well when you're dividing two integers. Let's jump right into an example and show the process of long division. So I would like to divide one polynomial by the other. The polynomial that you're dividing into is called the dividend. The polynomial you're dividing by is called the divisor. And for this to work, the divisor has to have a degree at least one less than the degree of the dividend. Now, how do we do the long division? So it's very similar to long division of numbers. We first of all write down the divisor, and then underneath a division symbol, we write the dividend. As we're writing the dividend, and the divisor for that matter, we want to make sure that the terms are in decreasing order of degree, so the powers on the exponents on the variables are going down. And if we notice that there are any missing terms, we want to provide a 0. Now, what do I mean by that? So notice that in the dividend, the final term is a constant, a term of degree 0. But in the divisor. But in the dividend, there's no constant term. We need to put a constant term in by using a 0 as a placeholder. Now we're ready to get started. I'm actually going to clean up a little space to make this a little easier to see. What we do is we really just look at the first term of the divisor and the first term of the dividend. And we ask ourselves, how many times does that term in the divisor divide into the term in the dividend? In other words, 2x times what would give me 4x cubed? And I think you'll see that if you multiply 2x by 2x squared, you would get 4x cubed. Where shall we write that? We'll write that above the division symbol, and we want to line up like terms, so I'm going to write it over the 16x squared term. Now, what this basically has done is it's given us an estimate of what the quotient is, just by looking at one term of each polynomial only. The step we do next is basically to see how close we are with this estimate. And what you do is you take the term you just got in the quotient, you multiply it by the divisor, and then you write the result underneath the dividend to see how close you are. So 2x squared times 2x is indeed 4x cubed, which is what we wanted. We also want to make sure that the 2x squared gets multiplied by the minus 3, and that would give me minus 6x squared. Now what we do next is to see how close we are. We actually subtract the second line from the first line, and subtracting is a fine way to say that, but what actually turns out to be a little bit easier to say is that we change the signs and then we add. So in that second line, what we do is we change the positive 4x squared to negative and the negative 6x squared to positive. And then by adding down the columns, we're really subtracting those two polynomials to see how close we are. But because we've changed the sign, we only have to think about adding. Now, 4x cubed minus 4x cubed is 0. And negative 16x squared plus 6x squared, because we changed the signs, is negative 10x squared. Now, to continue the process, because this is basically saying that we did not come out evenly, what we generally do is we bring down one more term. So we copy one more term from the dividend, and then we start all over. We ask ourselves now, and I'm going to clean this up a little bit just so we can start again. We ask ourselves now, how many times does the 2x divide into what's left. In other words, how many times does the 2x, the first term of the divisor, divide into negative 10x squared? What do you multiply by 2x to give you negative 10x squared? And I think you'll see that that answer would be negative 5x. Again, to see how close you are, you multiply negative 5x times 2x. That gives me negative 10x squared, which is what we want. And negative 5x times negative 3, which gives me positive 15x. That's the next approximation to the quotient, essentially. Okay, now to see how close we now are, we subtract these two lines, or better, or more efficiently, we change the signs. The negative becomes a positive, the positive becomes a negative, and then we can simply add. Negative 10x squared plus 10x squared would give me 0. 17x minus 15x is 2x. And then we bring down one more term. And then we try one more time. And we ask ourselves now, how many times does 2x divide into 2x? All right, that would just go one time, and we line that up over the constant term. Again, I'm going to clean that up a little bit, get rid of that. So we would now take the 1 times the 2x and the minus 3, and write that down here. And one last time, we will change the signs, positive to negative, negative to positive, and add. How do you know you're done? You're done when there's nothing else to bring down. Once you have finished that, then the polynomial you see on top of the division symbol is the quotient, and the final result of the final subtraction is called the remainder. Then, by way of reminder, we write the dividend divided by the divisor as the quotient plus the remainder over the divisor. So very much like when we do long division of numbers, what we would do is we would write our answer as 2x squared, I have to look back, minus 5x plus 1. That's my quotient, plus the remainder. The remainder was 3. Look back and see. And the divisor, this is the divisor over here, is 2x minus 3. Quotient plus remainder over divisor. And that's how you do a long division of polynomials. Now, before we leave this topic, I want to show you a little sidebar that among other things, is going to give us a way to check whether we did our division correctly or not, but it actually will do much more for us later on. Now, this is a theorem that goes by the very kind of pretentious name of the Euclidean algorithm, developed by an ancient mathematician by the name of Euclid. And although this will look a little bit complicated, we'll be able to state it in words very simply. Suppose you have two polynomials, f and g. Now, just to give it away, the f is the polynomial you're going to divide into, called the dividend, and the g is what you're dividing by, the divisor. And f of x, the dividend, has to have higher degree than g of x, and g of x has to have a degree at least 1. Then there will always be unique polynomials called q of x and r of x, which are the quotient and the remainder, that will enable you to make this multiplication statement, which I'll state in a different way a little bit later, where the degree of r of x is less than the degree of g of x. Now, really, all that is saying is that the dividend, which is the f of x, is equal to the divisor, the g of x, times the quotient plus the remainder. The dividend equals the divisor times the quotient plus the remainder. So let's suppose, for example, that we have successfully divided these two polynomials. This is the example we just did. And we have in here the polynomial we divided into, which is my dividend. The polynomial I divided by, which is my divisor. I got a quotient. And then I expressed the remainder over the divisor again. The Euclidean algorithm says that the dividend should be equal to the divisor times the quotient plus the remainder. That essentially, among other things, gives us a way to check. So let me show you how that would work. What we want to do is we want to start with the divisor, that's the 2x minus 3, multiply it by the quotient, that's the 2x squared minus 5x plus 1, add the remainder, divisor times dividend times quotient plus remainder, and if we have done everything correctly, that will equal the dividend. Let's see. So to check this, we would need to multiply these first two polynomials, and we do that by the distributive law. We take the 2x and we multiply it by every term of the second polynomial. So 2x times 2x squared is 4x cubed. And then 2x times minus 5x is minus 10x squared. 2x times 1 is 2x. Then we do the same thing with the second term of our divisor. We'll say minus 3 times 2x squared. That's minus 6x squared, just that one. Minus 3 times minus 5x is 15x. And finally, minus 3 times plus 1 is minus 3. Finally, plus 3, that's the remainder. That's the divisor times the quotient plus the remainder. Let's combine any like terms that we see, and I do see some. There's nothing to combine with the 4x cubed, but these are like terms, and they would combine to give me negative 16x squared. And these are like terms, the 2x and the 15x, and they would combine to give me 17x. And finally, these are like terms, and they would combine to give me 0. So this is what I get, and lo and behold, that indeed is the dividend. So the divisor times the quotient plus the remainder is the dividend, and our result checks. Hold on to this very elegantly named Euclidean algorithm, however, because you'll see later that it also implies many other useful things, which we will see. Take care.